Hey dear students, now we are going to go to another tutorial problem, and here we are going to change decimal numbers to fractions, a over b form. So here we do have decimals being divided into two, terminating and non-terminating paired decimals. So in this tutorial I'm going to show you how you can change these decimal numbers to fractions form. So as usual, your subscription of this channel is highly important because it encourages me to do a lot of tutorials like this in order to support you students. So as usual, I need to have your subscription, please, instead of watching without subscribing it. So directly let's go to the tutorial. The question number 11, it says express the following decimal numbers in the form of fractions. So you are given with 630.0350. Dear students, I brought this for you intentionally because if you observe the last zero here, it will be meaningless. Whenever you do have, you see a zero after a decimal without having another non-zero number behind it, we can discard that zero. Okay, we can do like that. So in order to change this to fraction form, we can consider this number to be 630.0350. You may consider this to be t because later I'm going to use a certain formula, and this is the same as this one, guys. D equals 630.035. log 0 is discarded as you see here because, as I tried to explain earlier, whenever you do have VC is 0 behind this decimal point, provides that you don't have any non-zero number to the right of it, you can you see avoid it. But this is something different. We are unable to, you see, eliminate this zero even though it is located to the right of these dots, because behind it we have a non-zero constant number. Because of that we are unable to discard this one, but possible to discard this because we don't have any non-zero constant number here. So no matter a lot of zeros you might have, don't worry, you can eliminate. Okay, so this number is actually the same as this one, 630.035. Now proceeding to the next, look, this is the formula that I'm going to try to explain to you. In order to change a decimal number d to, you see, a fraction over b form, what you need to do is multiply the given d by 10 to the power of n over 10 to the power of n, where n representing the number of digits after the decimal. For the time being, for instance, if you consider this example, how many digits do we have after the decimal? Count, please. 1, 2, 3. So we can multiply this by 10 to the power of 3 over 10 to the power of 3. So let's proceed right away. So this is going to be, look, 630.035 times 10 to the power of 3 over 10 to the power of 3, as can be shown, because n is 3. Now going to the next step, look, this is, you see, the decimal point. So whenever you multiply, you see, decimal number by a certain exponential expression like 10 to the power of n, what you need to do is you have to move the decimal to the right, you see, passing through any number of digits. If you are multiplying by, say, a positive exponent, this decimal is going to move to the right. But if you are multiplying by the negative exponent, this decimal will move to the left. You see? So for the time being it is positive 3, so we need to pass 3 digits. So take this point, now move 1 unit to the right as you see, and then move again, you see, 2, and then finally when you come to this, you see the point will be out. So what is remaining here is 630,035 alone. And here we have 10 to the power of 3, so 1000 comes. So guys, 630.0350 is identical to this fraction. So if you want, you can further simplify this in order to change to the simplest form. Otherwise, you can put this one as it is, no problem. Now what follows is another one, 0.003400. Look, students, again here. After this decimal, you see, even though we are having a non-zero number here, you see, even though we are unable to eliminate these two zeros, these two can be discarded because we don't have, you see, a non-zero constant number to the right of them. For one thing, they are placed after the decimal. So we are unable to, you see, we are unable to eliminate the first two zeros, but possible to eliminate these two. Now, how can we change this to fraction? As usual, let's call this to be d. So you see, now, as we did before, what we need to do is, you see, we can eliminate the last two zeros, as you see. So we can directly apply now our formula, which is d equals d times 10 to the power of n over 10 to the power of n. So how many digits do you have after decimal? Look, 1, you can count, 1, 2, 3, 4. So in place of n, we are going to take 4. So you will take this number as it is in place of d, then 10 to the power of 4 over 10 to the power of 4 is going to come. Look, it is written. Now what follows is, here you need to move this decimal to the right direction, passing through 4 digits, because the number of n, the value of n here is 4. So as you are doing so, look, this point comes here, look, 1, 2, 3, 4. So the point will be what? Out. Then you do have 3 zeros, 34 points. Look here, these 3 zeros do not have meaning, so we can cancel that, and then 34 over 10,000 can come, because 10 to the power of 4 makes 10,000. So proceeding to the next one, we have here 2010 or 2010.0301. So here we are unable to discard this 0 because we do have a non-zero constant number 3 to the right of it, and we don't have 0 to the right of 1 now, so we don't have any 0 to be discarded here, so we'll take the number as it is. So consider this to be d, as usual. So what we need to do is just apply the formula we have, d times 10 to the power of n over 10 to the power of n. So guess what n is going to be? Look, what do you have after the decimal? How many digits do you have? 1, 2, 3, 4. So you do have n to be 4. So directly apply this 1, 10 to the power of 4 over 10 to the power of 4. So this decimal is going to move out from this number because we need to go 4 digits to the right. And then you see 20,100,301 divided by 10,000 is going to come. I hope you have understood how you can change terminating decimal to fraction. Up next is another one. You see, another question. So you are asked to find the non-terminating decimal to fractions. Students, these kind of fractions are called non-terminating periodic decimals. Basically, we have also non-terminating non-periodic decimals, those that are called irrational numbers. But these are rationals, okay, because they are decimal numbers having, you see, a non-terminating form but periodic, okay. So how do we change this number to fraction form then? Take d to be 3.4, repeating again as usual. Then what comes next is make d to be d times 10 to the power of k plus p minus 10 to the power of k over 10 to the power of k plus p minus 10 to the power of k. What are k and p? Let me just explain. Students, k represents the number of the number of digits that are constants after the decimal one. P represents the number of digits being repeated after the decimal. So you see, in such a way we can determine what k and p are. So for example, if you consider 3.4 repeating, you see, what do you have after the decimal? After the decimal you do have 4 being repeated. So how many digits is repeating after the decimal? Only 1, and that is 4. So take in place of p 1. And how many digits do you have after the decimal without being, you see, repeated? The constant one, we don't have any number here to the right of the decimal, so k is going to be 0. So look, everything is now done. In place of k we took 0, in place of p we took 1. Then we have is, look, k is 0 again, so it will be like this. Then further simplification, make this one 10 minus 1, 10 plus 0 plus 1 makes 10 minus 1, 10 minus 1, 3.4 repeating. So now here what we need to do is, you see, you must not, you see, perform this operation first. Instead you need to apply distributive property, distribution of multiplication over subtraction. Now as you're multiplying 3.4 repeating times 10, this point comes out, and then 34.4 repeating is going to come, because this is, mind you, 4, 4, 4, it goes in such a way to the right without any limit. So as you are moving this point out, 34.4 repeating is going to come. And when you multiply this by minus 1, it will be 3.4 repeating again. So what comes next is the following. Look, 10 minus 1 is 9. So as I tried to explain, this is 34.4 repeating minus 3.4 repeating. This comes directly from this one. Look, 3.4 repeating times 10 makes 34.4 repeating, and this times 1 makes the number itself. The 9 comes as it is. As usual, 34 minus 3 makes what? 31, right? 31 over 9. This is 31 over 9 because 4 repeating can be cancelled by 4 repeating, so you do have 31 over 9. How do you assure whether you are right or not? Directly divide this by this. You will obtain 3.4 repeating. Okay. Now what follows from this next is you see 2.56 repeating. What do you mean by saying this? Students, this means 2.56565656. These two digits are going to repeat again and again. Okay, in the first case it was only 4, but now we do have 2 digits here, 565656. Do we have a digit after a decimal being constant without being repeated? We don't know. So k is going to be 0 again, but we do have 2 digits being repeating, so in place of p we are going to consider 2. So as usual, take d to be 2.56 repeating, then the next one is going to be using the formula d equals d times 10 to the power of k plus b minus 10 to the power of k over 10 to the power of k plus b minus 10 to the power of k. As I said earlier, what you need to do is k is 0 because we don't have, you see, a constant number after the decimal over here. And p is 2 because we do have 2 digits, 5 and 6, being repeated. So in place of k, take 0, p, 2, then have everything here. Then what you need to do next is, you see, 100 minus 1 over 100 minus 1 can come because 0 plus 2 makes 100. And then now look, we need to multiple, look, this by 100 first. Don't perform this operation first. 100 minus 1, 99, 100 minus 1, 99, because it will be meaningless, okay? So instead you need to apply distributive property. So when you multiply this by 100, you are forced to move this decimal passing through 2 digits to the right. So this turns to be 256.56 repeating. Reason, because as I said, this is nothing but it is 2.565656. These two are repeating, you see, to the right side. So as you are moving this point, you see decimal point to the right, this is going to be 256.565656, which actually is 256.56 repeating. Then when you multiple again, you look this with 1 or by 1, this will be what? The number itself, 2.56 repeating. And 100 minus 1 makes 99. So in such a way, we can perform this calculation. Look, here it is, 256.56 repeating minus, when you multiply this by 1, you see the number comes as it is. Now everything is arranged in such a way that we can simplify in a better way. So 56 repeating, the two can cancel each other. Then 256 minus 2 makes 254. So as usual, 254 over 99 comes. Is there a means of simplifying this? I think 2 plus 5 makes 7, 7 and 4, 11. No, just have it as it is. So dear students, it is in this way that you can do. Basically, there is also another method where we can apply. I'll show you in the next slide. But the idea is, you see, in order to change these kind of numbers, you see, non-terminating periodic decimals to fractions, please try to apply such approach. Just a matter of understanding the formula and applying it.